Let us start with the topic that is understanding the reversible reactions. We will study about the equilibrium constant and about the Le-Chatelier's principle. So this is in the equilibrium chapter, that is chapter 6 of class 11th NCERT. Let us start. Okay, so firstly, let us understand what is chemical equilibrium, So the word equilibrium itself, it suggests that, it's kind of a state of balance that, okay, in reversible reaction that can, for example, if I write A plus B gives C plus D. So this symbol means the reaction is reversible. That is, A plus B can form C plus D and the reaction can go backward also, right? So in reversible reactions, we get to see this equilibrium. So what is the state of equilibrium? It is where the rate of the forward reaction, that means the rate of formation of products is equal to the rate of formation of reactant. There is like a balance between this equation. That means suppose if the reactants are the products are formed by like a speed of 10 molecules per second, so similarly the reactants will also be formed by a speed of 10 molecules per second. So when the rate of forward and the backward reaction are exactly equal, we say that the equation has achieved equilibrium. Right now the equation is in the state of equilibrium. Okay, what is the word dynamic equilibrium? Dynamic equilibrium, the word dynamic means something moving, right? That means the reaction has not stopped. It appears to us that the reaction has not, the reaction has stopped, but A and B, they keep on combining to become C and D, and C and D, they, convert to A and B. Since the rate is same, we think that, that the reaction has stopped, but it is not stopped. The products are still being formed and the reactants are also still being formed. So hence this type of equilibrium, we call it a dynamic equilibrium. So basically the concentration of the reactants and the products, they become constant. That is the thing. So just imagine this, you must have played tug of war where, where there's a big rope and two teams are pulling it. So just imagine that both the teams are pulling the rope with the same effort, right? So what will happen? The center of the rope will not move, right? Because team A, let's say there are two teams, like there are these kids, team A, and there is another team B. Both of them are pulling with the same force. So the rope will not move, the center will not move, right? So it will look as if, they are stationary, they're not applying force, but they are applying force, right? So basically, this is what happens. Equilibrium is a state of balance, where the forward and the backward reaction, the rate of forward and the backward reaction is equal, right? And the reaction keeps on continuing. The products are being formed, reactants are also being formed. That state is known as a dynamic equilibrium state. So let us move forward. Today we are going to study about the equilibrium constant Kc. What is the equilibrium constant Kc? So it is a value that shows us the relationship between the concentration of products and the concentration of the reactants at equilibrium. So at equilibrium, when once the equilibrium is attained, what is the concentration of reactant, what is the concentration of products, right? Okay, and it also tells us the extent to which a reaction will proceed. That means when a reaction will attain equilibrium, right? So for any general reversible reaction, let us say this. Okay, this is a reversible reaction. This symbol means that, A and B combine to form C and D. C and D combine to form A and B. So reaction works in both directions, right? Forward and backward. So when the rate of the forward and backward becomes equal, we say that, okay, the reaction, it has attained equilibrium. Now, what is equilibrium constant Kc? How do we write it? It's very simple. So how do we write it? Kc is equal to the concentration of the products raised to their coefficient. So basically the small c is the coefficient, right? Raised to their coefficient, right? Divided by the concentration of reactants raised to their coefficients, right? Okay. Where A is the concentration, this A, B, C, D, the capital A, C, D, it denotes the concentration of the reactants or the products which are present in like, molar concentration, which are present in terms of molarity or molality. A, B, C, and D here are the stoichiometric coefficients of the particular reaction. I hope you got it, how to write the equilibrium constant Kc. Now let us move forward. Okay. So again, let us revise. It is the concentration of the products raised to the stoichiometric coefficients divided by the concentration of reactants raised to their stoichiometric coefficients. Okay, so what does the value of K tells us? Let us understand. So if Kc value is greater than 1, okay, so if it is greater than 1, isn't it in maths, you must have observed that if the numerator is greater than the denominator, let us understand 10 by 2, right? So the answer is 5. Basically, it is more than 1, right? So if the numerator is more, so in this case, if the numerator is more, what does it mean? That the products are more, right? The concentration of products, if they are more, so Kc value will be more than 1, right? Because the denominator is less. So Kc is greater than 1 when the concentration of products is much greater. So if the concentration of products is much greater, the reaction, it favors the forward reaction. Okay. Kc value is 1. So if I write, mathematically, if I write 2 by 10, so this answer would be 0.2. It will be less than 1. Why? Because my denominator is more. So if the concentration of the reactants is much more greater than the product, right? So what will happen if the concentration of reactants is greater? Then Kc value becomes less than 1. Okay, so in this type of reactions, what will happen? The reaction will, it will favor like a backward reaction. Okay, it favors a reverse reaction. Now let us understand, if Kc is equal to 1 or almost equal to 1, that means the concentration of reactants and products are comparable, right? Or the concentration is usually the same. Okay, that is what we can understand. So Kc value tells us a lot of things. If it is greater than 1, means the products are in greater quantity. If it is less than 1, means the reactants are in greater quantity. If it is equal to 1, means the reactants and products are equal. Okay, now let us move on to the next topic of this chapter, that is known as the Le-Chatelier's principle. It is a very interesting principle. Basically, when a system at equilibrium, so if a system is at equilibrium, what does it mean? That means now everything is balanced, right? The rate of forward and the backward reaction is same. But if you bring out a certain change in the system, right? That is, you change the temperature, you change the equilibrium position. How do you change the equilibrium position? By changing the, okay. So let us see, it's written here. Whatever we do to the system will try to oppose it to restore the balance. Let us understand how can you change the equilibrium, or how can you bring a stress on the system? That is by changing the concentration, by changing the pressure, or by changing the temperature, right? Let us understand. Basically, the system will try to go back to its original position. For example, A and B are forming C plus D. Okay. So what do? You remove certain amount of product, you remove it, right? Now the amount of C and D becomes less. So what does the system says that no, I need to restore equilibrium back. So more and more amount of product will be formed, right? So that now again there is a kind of equilibrium between the reactants and the product. So let us understand what does it say. So in the exam, it is asked, write down the definition of the Le-Chatelier's principle. It says that when a system is at equilibrium, right, and if it is subjected to certain change, that is the change in concentration, pressure, temperature, the system will shift its equilibrium position to counteract the effect of the change. That means the system will shift its equilibrium such that it wants to restore its equilibrium back, right? It will shift the equilibrium. Okay, so whatever you do to the system will try to oppose it to restore the balance. Let us understand with the help of an example. For example, we have, Haber's process. Haber's process is the formation of ammonia. So, for example, I have nitrogen, which is in the gas form, hydrogen, which is in the gas form, okay, which gives me NH3, that is ammonia. So, if you add a substance, the equilibrium will shift to the opposite side to consume what was added. For example, I am adding more of hydrogen, okay, I increase the amount of hydrogen. Now, what does it say? If you add a substance, the equilibrium will shift to the opposite order. Like I have added it to the reactant side, right? So the reaction will shift to the product side towards the right side to consume this hydrogen and make more products, so that the reaction is how it was before. So let's say if I add more amount of hydrogen, the reaction will move towards the right hand side to produce more NH3, right? And to consume this hydrogen. So again, there is a balance, there is equilibrium, okay? Now, if you remove a substance, for example, in this reaction only, that is the Haber's process, this is a balanced equation. If I continuously keep on removing ammonia, so my balance is disturbed, what will happen? Nitrogen and hydrogen would combine together to make more and more of ammonia, to basically bring the equation to the state where it was, in the state of equilibrium, right? So Again, if you are removing ammonia, the reaction will move forward to make more ammonia because it wants to restore equilibrium. Okay, so this is about changing of concentration, how changing of concentration affects the equilibrium. Okay, next is, okay, you are changing the pressure. Let us understand. So this is, pressure is, it is considered only where the number of moles of gas on the reactants and product size are different. Okay, let us understand. We have, so because I will explain it to you now. Let me write the equation. Okay, if you increase the pressure, the system will try to reduce the pressure. Okay, so let us say you have increased the pressure, right? So here there are 4 moles, right? 4 moles of gas, and here there are 2 moles of gas, right? So if we have increased the pressure is more here. See, because in a container, let us understand, in a container, if there are more molecules, right? There are 4 molecules on the reactant side. If you increase the pressure, now these molecules are moving with a faster speed, right? And the pressure is more because of more molecules are there, the pressure would be more. So it would try to go in the direction where the pressure is less to minimize the pressure. So it will go into the right hand side, right? To minimize the pressure, because uh, ammonia is there, there are just 2 molecules. So the pressure is less in the side of ammonia, because pressure is more where the number of moles are more, right? There are 4 moles of gases here. So the pressure is more on the, on the left hand side. So the reaction will move towards right hand side. But if you decrease the pressure, let's say in the entire system, I have decreased the pressure has decreased. Okay. Now the pressure is less. So what will happen? I want to, increase the pressure. So I know that here there are 4 moles. So my reaction will shift to left hand side, because here the pressure will be increased because there are 4 moles of gases, right? If I produce more and more gases, so they will exert more force on the walls of the container and the pressure would increase, right? So this is how the pressure affects the rate of the reaction. Next is a daily life example, like carbonated drinks. We have carbonated drinks. So basically the carbon dioxide in the gas, is converted to carbon dioxide in the liquid. Basically, we dissolve it in the liquid. So you must have seen in videos, like how carbon dioxide is, it is dissolved in the liquid. We have to apply a lot of pressure. You cannot do it at home. At home, you cannot make carbonated drinks. You have to make it in the factories, right? So inside a sealed bottle, when the bottle is sealed, it is packed with carbon dioxide at a very high pressure, right? So the pressure on the equilibrium to the right and the left, the pressure is same, right? But so now when the bottle is closed, so the pressure in the liquid and on the top is same. But when you open the bottle, you release the pressure, right? You release the pressure, right? So to counteract this, the system tries to increase the pressure. So the equilibrium shifts towards the left, right? So equilibrium shift towards the left. So the gas dissolved in the carbon dioxide. So basically now you have, you open the bottle, you release this carbon dioxide, which is there in the gas form on the top. So basically carbon dioxide that is dissolved in the liquid would try to come back to achieve the, equilibrium. So basically what happens, slowly, the carbon dioxide dissolved in the cold drink, it starts to, come out of the system of the dissolved liquid. Hence, you would see after some time, after you keep your cold drink for 2-3 hours, the fizz is all gone, right? So the dissolved carbon dioxide comes out of the liquid in the form of bubbles, right? Okay. Let us understand how does the rate of the reaction change, right? If you are changing the temperature, let us understand if you increase the temperature. So now this depends on the endothermic and the exothermic reaction. Okay. Let us understand for the exothermic reaction. Okay. If there is a reaction which is exothermic in nature where the heat is released, right? So here the heat is released. And if you increase the temperature, the equilibrium shifts in the direction that absorbs the heat, right? So basically, if it is the exothermic reaction, it shifts towards the left, because the forward reaction is what? The forward reaction is exothermic. That means here the heat will be released. So lot of heat will be produced. But the backward reaction is endothermic, which absorbs heat. So to, control the amount of heat to reduce it, the reaction will go backward. Okay. But if we increase the temperature and let's say the reaction is endothermic. So now, the reaction is endothermic. That means, it absorbs, right? It is absorbing heat. So what will you do? The reaction will shift towards the right then, right, to absorb the heat. Okay. So I hope you have understood this. What happens during the decrease of temperature? So if you decrease the temperature, that means we are removing the heat, right? So the equilibrium will shift in the direction that produces heat. For example, this is the exothermic reaction, and I decrease the temperature. I decrease the temperature, so the equilibrium will shift towards the direction. Basically, if this direction is exothermic, what is the exothermic reaction? A reaction in which heat is released. Exo means out, right? Thermic means heat. So heat is released, right? So I have this reaction A plus B gives me C plus D, where if my products are formed, more and more products are formed, heat is released, right? Now what I do, this reaction is there in normal conditions. What do? I come here and I decrease the temperature. Okay, I decrease the temperature. Now I am basically applying certain stress, certain change. What will the reaction say? That the reaction will say, no, we need to go back to our initial condition, right? So what will the reaction try? Try to increase the temperature because it was higher at first. I decreased it. So the reaction knows that if I make more and more products, the amount of heat will be released, right? Since it is an exothermic reaction. So the reaction will proceed in the forward direction, the direction that produces heat, right? So this part is a bit tricky because we need to be very clear with what is exothermic reaction, what is endothermic reaction. But the key is you need to do the opposite, right? Basically, if we need to go in that direction, if you're increasing the temperature, we need to go in that direction that decreases the temperature to come back to normal, right? So that is the thing that we need to remember here. So let us again try to understand what is about the Lee-Chatelier principle. It states that, Lee-Chatelier principle states that whenever any system is in equilibrium and you change its equilibrium, so the system tries to come back to its original position, right? So that is Lee-Chatelier principle. Okay. Let us understand about catalyst very quickly. Okay, a catalyst is something, that speeds up the rate of a reaction, both forward and backward, but it does not take part in the reaction. Like it will not form the products or it will not form the reactants, right? And it will not change the position of equilibrium, right? It cannot change the Kc value, but equilibrium will be attained faster. Cannot change the K value or the Kc value, but the equilibrium will be attained faster because what does it do? It increases the rate of the reaction, right? Okay, so you won't get more product by using a catalyst. You will just get it very fast. So why do we use this catalyst? Basically, in Haber's process, that is the process of, making ammonia. We use iron as a catalyst. You know why? So that we can make ammonia faster, because we want our industrial processes to be faster so that it saves time, and in less time we can make more and more products. That is why in industries we use catalyst. In process of making sulfuric acid, we use vanadium pentoxide as a catalyst, right? Why? So that the reaction, it happens at a faster rate, so we also save time, right? Okay, so I hope you understood what is the meaning of a catalyst. Let us do some questions. So these are homework for you. The first question is, for a reaction at equilibrium, which statement is always true? So just try to, answer this. Okay, what happens? There's this reaction. What is happening if you add more oxygen to the system? Where will the equilibrium go? Right? Will it go towards the left? Will it go towards the right? Basically, you have increased the amount of oxygen here, right? So basically what the system will try to do, it will try to deplete the amount of excess oxygen. How it can deplete the excess oxygen? By making more of the product, right? So equilibrium shift towards the right. Okay, and so you all can just pause this video, try to do question number 3 and 4, okay, and then check your level of understanding. Okay, thank you so much. And if you have any doubts, if you want to study this topic in detail and in deeper, we can connect through Urban Pro. Yes. Thank you so much.